This lesson is on solving systems by elimination using addition. Let's solve the system x plus 2y equals 7 and 3x minus 2y equals negative 3. Now your goal in the elimination method is to create coefficients that are opposites of each other on your chosen variable. If you notice in the first equation, we have a positive 2y. And in our second equation, we have a negative 2y. We would describe those coefficients as opposites of each other. So we can solve this system by elimination using addition. So that means we're going to add the corresponding elements of these two equations. So 1x plus 3x gives us 4x. 2y minus 2y adds up to be 0, and therefore the y's are eliminated. And 7 plus negative 3 gives us 4. You'll notice the resulting equation has just a single variable of x in it, so we're going to be able to solve that by dividing both sides by 4. And that gives us that x is equal to 1. Now remember, when you're solving a system of equations, you're finding that point of intersection of the lines that the equations form. So we know that our x-coordinate is 1, but what we need also is a y-coordinate. And we get that by plugging 1 in for x in any of the original equations. So I'm going to choose to plug into the first equation. X plus 2y is equal to 7. I'm going to replace x with 1 and solve for y. So I'll subtract 1 from both sides. That gives me 2y equals 6. And then I'll divide both sides by 2 and get that y is 3. So it appears like our point of intersection is 1, 3. But we could use the second equation to test that. Let's see if plugging this ordered pair works in the second equation as well. 3x minus 2y is equal to negative 3. Let's substitute 1 in for x and 3 in for y. So that gives us 3 minus 6 equals negative 3. And since negative 3 equals negative 3 is a true statement, our ordered pair does satisfy both equations and is therefore the solution to our system. Let's try another example. Let's solve the system 3x plus y equals 20 and x plus y equals 12. Now remember, our goal is to create opposite coefficients. We're close. Our coefficient of y in the first equation is 1. The coefficient of y in the second equation is 1. But we would describe these as matching instead of opposites. So what we're going to do is maintain our first equation, 3x plus y equals 20. But we want an opposite on y in the second equation. So our opposites rule tells us to take the opposite of every term in that equation. So I'm going to take the opposite of x and get negative x, and the opposite of y is negative y, and also the opposite of 12 is negative 12. So now if we look at our coefficients, we have created opposites. We have a positive 1 and a negative 1y. So we can solve this system by elimination using addition. So adding up the corresponding terms, 3x minus x gives us 2x. 1y minus 1y zeroes out, and therefore y is eliminated. And 20 plus a negative 12 is 8. So dividing both sides by 2, we get that x is 4. Now to get our answer for y, we plug that answer of 4 for x into either one of the original equations. I'll just pick the first one. So 3x plus y is 20. We're going to substitute in the fact that x is 4. That gives us 12 plus y is equal to 20. And subtracting 12 from both sides, we get that y is going to equal 8. So it appears our solution would have an x-coordinate of 4 and a y-coordinate of 8. But let's use the second equation as a test. Our second equation tells us that x plus y has to equal 12. So replacing 4 for x and 8 for y yields the equation 12 equals 12. And since that's a true statement, Our ordered pair does satisfy both equations and therefore is the solution.